Ahmed, and my project is the prediction of the stock prices using hybrid LSTM transformer models. And the objective of my project would be to predict the stock prices using three important LSTM and transformers models, which are deep learning models, which works well on the time series data. So we have stock prices, which are actually a time series data. So that would be better for the models. So that's why we are using these smart models to predict the stock prices. And finally, we will compare the models individual performance using the most accuracy forecasting approach. And the approach would be simple, like as the other projects. The first process, we will pre-process the data set using the remove null values and the stuff like that. And then we will create some sequences. It means that we will create subsets of the data depending on the time step, and the performance would be obviously better instead of working as a whole in the of the whole data set. And the finally we will divide the data or split the data into training and testing data. And then finally we will evaluate the performance using the MAE or MSC and R squared matrix. And the outcome would be a hybrid transformer LSTM achieved high accuracy and the robustness. Instead, we will compare it with with the individual performances like LSTM and transformer. The hybrid model works well. And finally, we have also tested this model using an unseen Tesla stock data. So the trend is obvious, and the output is of actually following the original trend, and the performance is really good. And here you can see the Apple closing prices starting from the 2000 to 2025. And you can see the trend is upward with the higher highs and higher lows. So we have to train our model to predict some close trend on the data set. If we talk about some literature view, I have studied that LSTM actually captures the short-term memory by using three important gates like input gate, forget gate, and output gate. So it actually uh, find the short-term dependencies, and the transformer actually carries the long-term dependencies, and it helps to identify the historical system of the of the transformer and of the of the trend, and the it helps to identify the prediction using the past data. And if we talk about the hybrid model, it actually a combination of the LSTM and transformers. So it would capture the local and the global trends, and it would be a superior predictive performance. And there are some research gaps. A few studies compares LSTM transformer and hybrid models on multiple data sets with ablation analysis. It means that the hybrid model works well. Instead, we use them the individual. And the our for sorry, here is the prediction pipeline. So in the diagram, you can easily see that in the first process is just the data pre-processing, like starting from the collection, then creating the data set, and then uh, creating the sequences manually for the better performance. After the dataset creation, we will use three models individually, and we'll train them on the dataset, the initial dataset. And then after the training of the model, we will predict some outputs, and we will compare or evaluate the individual models depending on some three matrices which I have explained earlier. And then the evaluation, obviously. And now I would like to move on some to the coding part. Here is my coding part. You can easily see. So in the first process, in the first step, the first cell, here are some important imports of the libraries, which would help us to write the code and get and use the already built-in functions like TensorFlows, NumPy, Pandas, and here is the Yahoo Finance library, which actually helping us to download the data set from the site. So here is the data preparations. In the first pass, we have downloaded the data using this library here, and here is the stock name, and here is the period of the stock data. So it's starting from the 2000 to 2025. So here up to here is our downloaded data here, and the final or the or the column, which would be the target column, is the close. So every row would have a close column, and that column would be used as a output of the previous output of that particular rows. By using this column, we will predict or train the model. And here is, you can see the table. um, the data set have originally five basic columns, and it would be a close, high, low, open, and volume. And each row is representing a individual candle in the chart or trend. And here is the some visualization of the data set. And here is the output of the initial data set of the apple, and you can see that the upward direction is, and the trend is upward. And here is the scaling and normalization values. Scaling actually means that in the stock prices, we have the values are starting from the zero and upward to the infinity. The values could be 2000, 3000, 5000, like this. But so instead of using that higher values or volatile values, the best possible results are would be on the lower values. So that's why we're just scaling the values from in the range, like from starting from the 0 and 1. So the every value would be rearranged to the 0 and 1 by using this function min max scaler. So we are just specifying the feature range 0 to 1, and then we have used this fit and transform and passes our data. So the here is the output of the array. So we have just passed this. You can see we are using our close column as a data as our target column. So we have just passing this data in the uh, min-max scaler, not the whole data. So it would be but much beneficial for our computation power as well of the model. So here is the uh, creating the data sortable for modeling, like we are creating the sequences of the data set, and we are using the time step, which actually is the length of the length of the rows or the data in the each sequence. So LSTM works well on the sequences, so that's why we are using them. So here are some parameters, important parameters. We are using the time step is equal to 100, which means that each sequence would have around 100 individual rows. And that here is the training size, which is actually 67%, and the remaining would be the test size. So here is the scaling of the data, trained data, and the testing data, and then we have created them the sequences of the testing and the training the sequence data set. And here is the transformer block. Here is our first model, which is a transformer model. So it actually getting some important parameters like inputs, head size, num head size, and ffm dim and dropouts. So layer normalization is basically it it is normalizing the data set or the values in the sequences from the in a particular range, which would be beneficial for the per model, and would be less beneficial for the overfitting of the model. And here is the multi-head attention, which actually using this num heads. So the num heads, the more the num heads would be, the more the performance, the more the relation between the columns would be created. So here is the multi-headed attention, which is actually a transformers main thing, and then we are using this layer normalization and dense here, and we are using the relo as activation function, which is actually giving us the values between 0 to 1, and not the negative values. And here is the transformer encoder, and then we have passed this inputs here, and then we have used the global average polling, which actually pulling the data set into subsets. And then here is the outputs, and we have passed these inputs and outputs. Like outputs would be the uh, output would be the target column, like close column, and the inputs. And then we have used the optimizer as Adam, and the loss mean squared error as the activation loss error. So here is the summary, and then we have trained the model over here. We are running the 50 epochs, and the base size is 64. And here is the evaluation and the prediction. And then after the prediction, we have again inversing the already min max scalar values. Like the values were in the 0 to 1 range, and we have, after the model training, we are again converting them to the original values. So after that, we have evaluated some matrices, and here are the results of the mean absolute error, root mean absolute error, and the mean squared errors. And these errors some performing well. I will show you the table of all these values of the all three models. Don't worry. And it is some and the visualization. You can see here as the visualization of the three: actual stock price, train predict, and the uh, test predicts. You can see in the blue ones, we were having the original stock prices, as I showed you in the earlier presentation part. Then we have using the transformer model. Here is the orange one. Up to here is the training prediction, and then up to starting from here is and ending here is the test prediction. So you can see the model working well in the this model. And here is the LSTM block, which is here is the sequential. That's why we have created the sequences using the time step. And then we are using the relo as activation function over here as well. And then here is the compilation of the model using the mean squared error. And then we are running around 50 epochs over here as well. And here is the prediction of the LSTM stock prices. So you can see there are some uh, gaps in the original and the actual price, original and the predicted trend. So we have to just, that's why we are that's why in visual LSTM it doesn't work well, because it only captures the short term memories. But for the long term dependencies and attentions, we have to use the transformer with the LSTM, so we can easily capture the actual trend, which would be more related towards the initial data set and initial trend. It is the prediction, again the evaluation depending on the four matrices. And then finally we have used this hybrid model by using the transformer and LSTM together. Again, here you can see the normalization, multi-headed attention, all the built-in functions we have used, and the same parameters here over. And then here is the transformer stage, and we have used the relay over here as well. And here is the LSTM part and the output. So by using this hybrid model, we have created some history over here, and then we are again inversing them. So here is our predicted models value: y predicted inverse, y test predict. So you can see as compared to the LSTM, our model is working well by using the hybrid model like LSTM and transformer, and is more closely towards the initial data or initial trend. So that's why the hybrid model working well. And here is the loss error as well, loss curves as well, and the valuation. So after training the model on the Apple stock data. We have used this model as validation for the Intel data set as well. Same process over here. All the code is the same. Just have change the data set. You can see the model is predicting the actual trend over here as well. And same is the case for the Tesla dataset as well, which is quite noisy, but we can actually improve the outputs because in the current situation we are just using the output as a predicted column, right? But if we want the input, here is the actual LSTM versus a true hybrid transformer of the Tesla. So the model is very close. So here is the coding part. So the final conclusion, here is the final conclusion that hybrid model is capturing overall trend in the Apple prices effectively, but there are some limitations as well. Currently, we are just using the column out open column as a predicted price. So we can after how we can easily create some more columns or the engineered parameters to find in our model and predict them more nicely, and we can easily use the inner circle trader terms like um the advanced terms and convert them to engineered features. And I think that would be too much advanced and would be much beneficial. And right now I have not included the news sentiments in this as well. We can scrape the data set from the news, and this is a actually a separate domain. We first have to scrape some data, and then we have to use that data for the prediction. So but nothing is impossible. We can actually create the this part as well to avoid the news sentiments. And then here are some references of my project. So that's all about my project. So if you have questions, let me know. Thank you, sir. Take care.